Edexcel Further Maths Core Pure 1 Specimen Paper, Question 2. This is a fairly wordy question, and if you glance down, you'll find that there is one question in all of this text, and it's worth 8 marks. So it might be worth, before reading through in great detail, skimming across, see if you recognize this format of question at all, and then reading what it's asked you for at the end, so that the question forms part of how you interpret the rest of the information. Form and solve a matrix equation to find, to two significant figures, the number of visitors for each of the theme parks in 2016. Now, if you've not read the rest of the question, not much of that will make sense, but at least you now know the topic. You're forming and solving a matrix equation. Now we look back and see what kind of information we've been given. We're told about 3 different parks. We're told how much profit each park makes per visitor. And we're told that each of the parks has a different number of visitors in 2017 compared to 2016. Gives us the proportions, so we've got a link between the visitors in 2016 and the visitors in 2017. It also gives us some extra information, the number of people visiting the 3 parks in 2017, the profit in 2016, and indirectly, the profit in 2017. Each of those different pieces of information can be synthesized or combined to give you equations. And so if you think about it, because we've got the 3 theme parks and we're asked to find the number of visitors for each of them, we're looking for the number of visitors to Park A, Park B, and Park C. That's 3 different unknowns that we're being asked to find. And if you've got 3 unknowns, you're going to need 3 pieces of information to find them. And that may be something as simple as, here's a piece of information, you can now find the first unknown, here's a second piece, you can now find the second, etc. But it's more common that you'll have something connecting all 3, and you'll need to solve a system of 3 simultaneous equations in 3 unknowns. Now the calculator can do this for you, so when we get to that point, it might be worth noting that we can solve simultaneous equations with 3 unknowns on the calculator just like this. You sub in the x, y, z and the constant value for each of your equations, and it'll give you your answers. It'll even tell you if there are no solutions possible or if there are infinite possible solutions. But it's not told us to do it like that. It's specifically requested we solve it as a matrix equation. So we've got to remember that there's a link between this system of equations you see here and matrices. Now, if you look on the screen, you can almost see that link. If we've got 0 x's, 0 y's, 0 z's, and then on the next line 0 x's, 0 y's, 0 z's for the next equation, this is essentially a 3x3 matrix. It's what you would get if you had a 3x3 matrix multiplied by the vector x, y, z. So we'll bear that in mind as we work through. My question plan for this question is going to be form 3 simultaneous equations for the 3 unknowns I need. Set up in the form of a matrix equation, solve the matrix equation to find the unknown values required. So that's what I'm going to do. And if each of these steps is familiar to you and you understand how they're going to work, you could jump ahead and give it a try. Maybe come back and watch the rest of the video once you've given this a try for yourself and see how efficiently you can do it. But I'm going to show you how the calculator can work alongside what you're doing by hand to make this process more efficient and yet still show everything you need to show to get all the marks. So let's start with the information we're looking for and the unknowns that I need. I'm going to start by defining those. So I'm going to say let x, y, and z represent the number of visitors to parks A, B, and C, respectively, in 2016. I'm defining them in that way specifically because of this final line. That's what they're asking me for, the number of visitors for each of the theme parks in 2016. I'm also calling them X, Y, and Z partly because that's what the textbook tends to do and exam mark schemes tend to do, but also because that's the way it might look in here if I were to put them in as simultaneous equations in the ClassWiz calculator. It's probably what I'm more familiar with using, so that's what I'm going to use. And as long as I've spelled it out clearly enough here, which one corresponds to what, X is the number of visitors to Park A, etc., then it shouldn't be a problem. If you want to use different variables, feel free. Now, how do I form the simultaneous equations? Well, to start with, this first bit of information doesn't seem to give me an equation. It tells me how much profit I make per visitor for each park. And then this tells me that one of the parks was upgraded, and that doesn't seem like it gives me much information, but we'll come back to it. And then during 2017, we've got information about how the number of visitors changed. 50% of the number of visitors it had before. Well, maybe that's what this statement is about. As Tech Adventure Park was being upgraded, it only got half the visitors it had before. But parks B and C had 25% and 15% more than they had previously. And then it gives me the actual number of visitors who visited the parks during 2017. Now, although I can't just say X add Y add Z equals something, because they've not told me how many people visited in 2016, I can construct something a little less direct, because they have given me the number of people visiting in 2017. So this is my first sort of key fact I'm going to be making use of. That 1,350,000. And I'd encourage you to use commas to make life easier, because otherwise you'll be counting and miscounting zeros here, there, and everywhere, and it's very easy to make mistakes with this. That's the number of visitors in 2017. I'm going to label it so I know which information I've used, and I can keep track, make sure my left-hand side and right-hand side of the equations match up and describe the same thing. Now, X, Y, and Z represent the number of visitors for each park in 2016. I can use these 3 bullet points to work out how that links to 2017. So there are only half as many in Park A. So 0.5 times X gives me the number of visitors to Park A in 2017. 1.25 times Y gives me the number of visitors to Park B. And 1.15 Z is the number of visitors to Park C. And there's my first equation. What else can we do? Well, the next bit talks about profit. Total profit of 39.15 million in 2016. Profit in 2016. How is this going to help? Well, profit is linked to the number of people by this fact up here, these 3 little facts: £30 per visitor in Park A, £26 per visitor in Park B, and £33 per visitor in Park C. So I'm going to say the profit in 2016 can be variously calculated, either just by writing it down, 395000. I'm going to keep everything in pounds so that I don't get confused with this. And since the money here is in pounds, I don't want to be writing this as 0.000 something 26. I'm going to keep everything in pounds on both sides of the equation. But if I get £30 per visitor in Park A in 2016, or in fact, this is not linked to a year, this is just how much profit they make per visitor. So we're assuming that's true in 2016 and 2017. But in 2016, they have X number of people and in the first park, and in that park, they make a profit of 30 per person. Similarly, £26 per person in the second park, and 33, I believe, £33 per person in the third park. So now we've got a second equation based on the profit in 2016. The next equation we're going to make, there must be a third one, we'll need 3 equations to solve for 3 unknowns, is the profit in 2017. And although they didn't give us this directly, they did say the profits dropped by 1% for 2017. So I know that on the right-hand side, I have 0.99 times 39,150,000. And on the left-hand side, I need to know exactly what the equivalent of this is. Now, effectively, I've already got both of what I need here. I know how much money is made per person in Park A, and in Park B, and in Park C. I just need to know how many people were in Park A, Park B, and Park C in 2017. That information I've already worked out here. So it's half as many as it was in 2016, it's 25% more than it was in 2016, and it's 15% more than it was in 2016. So there we go. It's a good idea at this point to simplify your equation, and you can either use your head or you can let the calculator do some of the heavy lifting for you. So 26 increased by 25% gives me 32.5. And finally 33 increased by 15% gives me 37.95. And on the other side of the equation as well, I'm going to find 99% of this number. So we get 3875850. And again, I'm going to try to keep the commas in there so I can make sure my numbers are at least the right size and I don't miss anything avoidable that I should be catching. Now I've got 1, 2, 3 equations, and I want to set this up in the form of a matrix equation. So of the steps that I'm trying to follow, I've done the one that's probably the most tedious, to be quite honest, and it didn't take a huge amount of writing down. It just takes careful reading and comprehension of what's being given in the question. How do we turn it into a matrix equation? Well, if we're solving a matrix version of a set of simultaneous equations, then we think of it as a matrix M, let's call it M for now, multiplied by input values x, y, and z, giving output values that presumably we know, so A, B, and C, whatever they happen to be. So the matrix form of this system of simultaneous equations will look something like this. Crucially, the matrix we will be dealing with should be a 3 by 3 matrix. And the values in it are going to be the values that we've just written out here. So 0.5, 1.25, 1.15. Those are the coefficients of x, y, and z. Remember, when we multiply a matrix, the first row gets multiplied term by term by the first column of what we're multiplying it by, and then we add the results together. So the second equation is 30, 26, 33. And the next one is 15, 32.5, and 37.95. We need to remember the results are basically the right-hand sides of those same equations. So 1,350,000, 39,150,000, 38,758,500. This is our matrix equation. So we've done the first part of what they said, form and solve a matrix equation. Well, we've formed the matrix equation. How do we solve it? Well, the important point here is that if we've got a matrix multiplied by an input, giving us an output, we can switch that whole thing around by using inverse operations. Just like with any equation, if I had x that had been, let's say, multiplied by a number to get an answer of 7, we would divide both sides by that number. If this m represented a more complicated function, like sine of x equals 0.2, you would do inverse sine of both sides. Applying the inverse matrix is effectively that. So when you apply the inverse matrix to the left-hand side, m inverse times m basically gives you the identity matrix, which leaves the x, y, z vector unchanged. So all we need is to find the inverse matrix of this and then multiply both sides by it. But the effect of multiplying the left-hand side by it will be for it to disappear entirely, leave us with just x, y, and z. The effect of multiplying the right-hand side will be to generate for us the solution vector. So this is what we're looking for. And I'm not even going to write out the inverse matrix. I'm going to use the calculator to do all of this. I've written down what I'm doing. I'm going to use the inverse matrix. Here's my matrix. I'm going to apply the inverse matrix of that 3 by 3 to this vector. And that's going to be sufficient to demonstrate to the examiner that you know what you're doing. And now look over here at the calculator. We'll see how to do it. We're going to need menu option number 4 for matrices. And we're going to start by defining our first matrix. We'll call it matrix A because it's the first one. And it's going to be a 3 by 3 matrix. We're going to type in these values. This is the one in red. So 0.5, 1.25, 1.15, 30, 26, 33, 15, 32.5, 37.95. There's my matrix. That's now done. And I can press Option and define a new one. I'm going to define the next matrix. It's actually going to be effectively a vector. So it's going to have 3 rows, but only 1 column. This is going to be what happens over here on the right hand side. So this is the bit that I'm going to apply my inverse matrix to. So it's 1350000 39150 38758 Now press Option one more time and we've got Matrix Calc. Now it says Matrix at the bottom of the screen, but it's waiting for a calculation. Pressing Option again, we choose the matrix we want, which is Matrix A, and then we use this x to the minus 1 button. We need to use x to the minus 1. We can't just use x with a power and put minus 1 in. The calculator only understands inverse matrices if we use this specific inverse button. We're going to do Matrix A inverse and multiply that by, choose Option, Matrix B. So I don't ever even see the values of the inverse matrix, and it is not necessary, I want to stress this, it's not necessary to work out that inverse matrix by hand and write it down. It is only necessary to show the method that we're using to get here. So this, you can see here, you can even scroll down to get more detail if you need to. This gives us our results, 400,331.7576. I'm going to give the full detail here for my answer, because I might as well. And it shows that I know to perform the correct calculations. And for the last bit, 355,010.7434. Therefore, there's two significant figures. Number of visitors to the 3 parks in 2016 were, and let's make sure we're answering the question. We want the number of visitors for each of the theme parks in 2016 to two significant figures. A lot of students will do all the clever stuff right and then miss the rounding that's required here. We want answers to two sig figs, and we want it for 2016. The fact that we defined our values as the 2016 values at the beginning is helpful because it means X, Y, and Z are what we're trying to find. But now we need to convert that back to saying Park A is going to be, well, 400,000 to two sig figs. B, 590,000, and Park C, 360,000. So I'm rounding each of these and giving my final rounded values as my final answer. Now, if you wanted a way of checking those answers, you could go